So students, we are going to start with our next experiment, that is to design and configure this simulation for subnetting of network and the static routing server, right? So if you go with the network design lab web course page, right, so you will find out under the third tab that there is an experiment number 4, that is for the subnetting of your network and the static, how to do the static routing, right, how to use that particular thing. Okay, so if you think with respect to the prerequisite, right, so whatever the that will be the required for this performance for this particular experiment, right? So the knowledge of basics concepts of the networking, obviously you must you must know the what are the different kinds of the commands which are which we are going to use to configure that particular routers and the servers, right? Then what are the different IP addresses scheme, right? So there are different classes of IP addresses. You must know at which time which IP classes you are going to use, right? Then IPv4 also the you must know what you mean by the IP version 4, right, and how to do router configuration by using some command line interface, right? So that also you must know, right? Then we will see there is I have divided this particular experiment into two parts, right? The first one is the part A, is basically will be required for this particular subnetting of your network, right? And the second part B, that is nothing but for the static routing protocol we are going to see, right? So we will discuss with there are the two types, right, the static routing as well as the dynamic routings, right? So in this particular experiment we will have as a part B as a static routing only, right? So in this, if you see the what are the different problem statements we have with respect to this experiment is concerned, right? So whatever the logical subdivision of your kind of the network, right, so it is nothing but the subnetting, what we can call, right? So now how to calculate this particular required subnet, right? So for the it will be depending upon the organizational requirements, right? So according to your organizational requirement, right, to how many subnets you want in your network, right, so that you need to calculate, right? So there is some formula on the basis of that you can calculate that particular subnet, right? And while doing this particular subnet for your network, right, you can also must be check that wherever you will there will be possibility of any further expansion of if any your network, right, then you must have some subnet in your hand, so that can be used in that particular scenario, right? Then we will also identify how this particular configure network, right, with and without subnetting, right, and what are the different benefits which subnetting is having, right? So that also you need to get it clear in this particular experiment, right? And then we will see how this particular in a part B, then we will see how that particular network can be give the static route to that particular network, right? So that the network traffic can be sent from one network to another, or within a sub network also, right? Then we will see how to configure all these things with the help of the command line interface, right, as well as from the GUI graphical user interface as well, or obviously in a Cisco packet tracer, right? So we will see all these both scenario, right? So part A and the part B, that is subnetting and the static routing, right, we will see. Okay, so if you see in this particular diagram, right, so I have this is nothing but one logical topology of the subnetting, right? So I have explained this in your lab manual, right, with the help of some our college example itself, right? So that is nothing but the scenario based I have given one example, right, on the basis of that why the subnetting is required, right? And if it is required, then how to calculate the subnet whatever the required thing, right, and how it can be configured in that particular router, right? So in order to use this particular subnetting network, right? So that also I have discussed on in that particular manual, right? And for with respect to the part B, right, so we need to provide here the static routing, right. So we need to manually update all the things in the routing table, right. So how to do that thing with step by step, and how to configure these particular routers, and how to add this static routing part in that particular in that particular routers as well, right. So I have explained all these things in part B with respect to the static routing configuration is concerned, right. So we will directly move towards this particular lab manual of it, right, and then we will do some hands-on the Cisco packet tracer regarding this, right. So let us move to that particular lab manual. Okay, if you see in this experiment number 4, right, so for the subnetting part, right, so subnetting I have already explained you, so it is nothing but some logical subdivision for your IP network, right. So it will be divided your network into two or more kind of the network, or we can call it as a subnetting part, right. So there are some advantage by using this particular subnetting, right. So for example, you can provide the security to the network, right. So if you for example, if you without subnetting, if you use any kind of the network, right, so every time the packet will be broadcasting, right, so that there might be a chance to have this denial of service, right. So it will be causes your the QoS parameters also for your kind of the network, right. So that to avoid all these things, right, so to provide the security, we can also use this particular subnetting, right. So it will be not affect on that particular QoS and all that things, right. Then also the second advantage, if you see, right, so the speed up the network, that improves the performance of the network, right. Also obviously if the packet will be not broadcasting, right, so whoever needed the packet will be send it from that one end to another end, right. So it will be improve the performance as well, right. And the third one, it allows the better organization of the resources, right. So whatever whoever is the end user, right, so for that we are going to send the packet, right, then it will be effective utilization of the resources in terms of this particular subnetting, if you concerned, right. So in this particular example, if you see, I have given one example of the A.P.Shah company, for example, right. So here if you see in this particular topology also, right, so it is nothing but the A.P.Shah network. So in this we have one router, one switch, and the 4 terminals we have, right. So these are nothing but the end users, right. So first of all, we will see the software developer. We have one software developer, we have one tester, we have one HR person, right, and we have one administration, right. So these are the 4 main departments, if you concern, right. And currently now here only one member will be there, right, and it will be attached to one switch, and via switch it will be attached to this particular router, right. So if you see the IP range for this particular network, it is nothing but in between the 192.168 10.1 to 10.255, right. So these are the some basic requirements of this particular software company, called it as an A.P.Shah network, right. So after some days, if you see after some of the period, right, this particular A.P.Shah network will grows, right, and it having some of the more members into a team, right. For example, if you see here, the architecture will be the same, just the number of count will be increased, right. So software developer before it's having only the one, now it having 3 software developer, right. Now it having the 3 software tester, right. So also the HR team different it having, right. And other one, it is also included the business analyst, data analysis team into that particular topology, or in that particular organization, if you see, right. So total there are 15 computers in that particular A.P.Shah company now in 1 year of the span, right. Then if you see how to configure all these things, right. So in previously we have discussed, or we have seen in our last few experiments, right? So in DHCP server, right, so how the DHCP server can be configured, right? So in that case, we have used the DHCP configuration to on the server, right? But now here in this particular scenario, right, we are going to configure this particular router as a DHCP, right? So through router, I am creating some DHCP pool, and from that the IP addresses will be dynamically allocated to all these end devices, right? So how to do that? Right, so for that you need to first of all give IP address to this particular router, right? So how to do that, right? So first of all you need to configure this particular router, right? And for configuring router you need to before this experiment we are going to give all the assignments and all that thing through GUI only, right? So from graphical user interface, right? But from this experiment we are going to start with our command line interface, right? So I will explain you how to do that in the command line interface, right? So for router configuration you need to just press first of all you need to type here the command en is nothing but the enable of that particular router, right? And then if you see the second command is config t, so it is nothing but the configuration t means for the terminal, right? So configuration terminal of this particular router, right? Then the third next command is your the interface fa0/0, that is nothing but your fast ethernet at the port of 0, right? So you need to provide some IP addresses to this particular interface, right? So I am giving here the IP addresses, IP space address space this 192.168.10.1. I am giving the this IP address to this particular router, and then the net mask for it, right? And this particular no shut command will be enabled on this particular router with this particular configuration, right? Then I am going to, as I mentioned you, I am going to give the DHCP pool to this particular router, right? So if you see here to configure configuration of DHCP pool, I need to fire a command IP space DHCP space pool space net1. So net1 is nothing but here the network 1, right? And then I need to provide here one of the network or whatever you need to provide the range of that particular IP address, right? So here if you see I am providing here 192.168.10.0 and net mask for it, right? That is 255.255.255.0, right? And also I am providing here the default router, right? Default router and DNS server, if you observe it, right? So it will be same whatever we have given IP address to my router, right? So the default router and DNS server is nothing but the IP address of your router, right? And just I am ending my DHCP configuration over here, right? And after that I am firing one more command, that is copy running dash config and startup config, right? To in order to make all these particular configuration changes, right? And running at the startup whenever that particular router will be start, right? This particular configuration will be run. So for that I am using this particular command, right? So this is nothing but for my AppSheet network which will be directly giving IP address to all this particular system dynamically, right? From this particular router itself, right? So all these things we need to see check, right? So if you see in this particular topology, right? So I am going to ping from this particular software developer SD1 to this particular tester 3, right? But if you see in this particular topology, right? So whenever I am going to send a request, right? So it will be goes to this particular router, right? After that this particular it will goes to this particular switch, right? And the nature of switch is again a broadcasting nature, right? So whatever the request comes to this particular switch, it will be sent to all the interfaces whichever connected with that particular switch, right? And whenever the acknowledgement is come from that particular any devices, right, then it will be again send it to that particular person which are requesting for that particular packet, right? So unnecessary all the departments here are disturbed, right? So unnecessarily the packet will the broadcasting, due to this particular broadcasting, it will be goes to each and every devices, right? So it will be affecting the quality of service of that particular interfaces, right? So so avoid this, right? So what we need to do is we need to avoid because if you see this particular network is very small, right? But if the network is very very large, right, then if the request now in this situation only one person is requesting, right, but if the simultaneously request comes, right, then there may be a chance for denial of service attack, right. So to for avoid this, we are going to we will require a subnetting part, right. So for that we are going to do a subnetting, right. So now, so for from this particular topology, what I am going to do is whatever the department are there, right, so I am dividing into the three parts, right. I am dividing into the three subnets, right. For example, software developer and software tester is in one subnet, HR department is another subnet, and for BA1 and DA1, that is business analyst and data analysis, for the one another subnet, right. So three subnets I am going to create here. So if you see here, right, so I have used instead of one switch, I am used here the three different switches over here, right, and through that I have connected all this software developer and tester. These are the HR1 and the BA, that is the business analysis and the data analysis part, right. So in that way I have regenerate or recreate our logical topology again, right. So if you see now we will see how to calculate this particular subnet, right. So we will require here the three subnet, right, and we have an our range of my IP addresses for this particular network, right. So you must know that the always, if you see the number of subnet, right, which should be always be calculated in the power of 2, right. For example, 2 raised to 1 if I am doing, right, so 2 raised to 1 is nothing but the 2, right. So but we require a 3 subnet, right, so it doesn't satisfy our requirement, right, because we want a 3 subnet and 2 raised to 1 gives me a 2, right. And also if you see 2 raised to 2, it gives me a 4, right, but our requirement is 3, right. So greater if you have any greater subnet, right, then it will be fine, but it should not be less than whatever the your requirement is, right. So if you are having this particular 2 raised to 2 equals to 4, then it is fine. So 3 subnet I am going to use, and 1 subnet I may use later on, that is nothing but for my future expansion, right. So you always need to think with that direction, right, for future expansion and all, or you can take it as reserved one, right. So if you see our IP address range is from the 10.1 to 10.255, right. So and if you check its subnet mask, right, so it is nothing but for the class C, right. So subnet mask will be 255.255.255.0, right. And if you write down this particular net mask in the binary, right, so it will be your all 1 all 1 all 1 all 0, right. So what you need to do is, right, so if you the first 24 bits, right, so these are nothing but your the network bits, right, and the last 8 bits, these are nothing but your the host bit, right. So to create all these 3 subnets, right, we need to take 2 bits from your the host portion, right. That means if you getting this particular 2 bits from the host portion, right, then your net mask will be your 255.255.255.192, and if you are going to create the 4 subnets, right, so that's why you need to divide this particular 192 divided by 4, so you will get it 64, right. So 64 in a one subnet you need to add it on, right. Okay, so if you see here also, so I have divided this particular subnet into the 4 portion, that is 0 to 63, then 64 to 127, 128 to 191, and the last one is 192 to 255, right. So this particular 192 to 255 can be I will use as a reservoir for my future expansion, right. So 10.0 to 191 I'm going to use for this particular topology be as a subnetting part, right? So how to configure then this particular subnet, right? So if you wanted to configure that, right, so you need to first of all give the whatever the router is giving you. For example, if you see in this particular diagram, right, so from the router you have the three interfaces, right? So all these three interfaces you need to first of all give the IP addresses first, right? So for this particular link I have on different IP address. For this particular link I have different IP address, and for this particular link I have different IP addresses, right? And along with that you need to also define a different DHCP pool for each and every subnet part, right? So that whatever the internet networking devices or end devices are connected with that particular subnet, right, so it will be getting IP address from that particular DHCP pool itself, right? So this particular software developer and software tester will get an IP address from this particular first subnet, right? This particular HR team will be get IP address from this particular link, and this particular business analyst and data analyst will get the IP addresses from this particular third subnet part, right? Then if you see how to configure then this in on the CLI, right, that is command line interface, right? So if you see, I am going to add on the router this particular interface, that is FA0/0, and I am giving here the IP address that 192.168.10.1, right? And whatever the subnet I am getting it from calculating that particular subnet part, right? So these are nothing but my net masks, right? So after that I am using the command no shut to enable this particular routing configuration to that particular router interface, right? Then I am here creating one DHCP pool and called it as the net1 to identify which DHCP pool I am creating, right? And for that if you see here the 192.168.10.0, as I mentioned, 0 to 63 I wanted to use in that particular subnet 1 part, right? So that network IP you need to give, and whatever the DNS server and default router if you see here, right, so these are nothing but my router's IP address as shown in this particular above FA0/0 IP addresses, right? So likewise you need to again configure the remaining two subnet part, right? So so for different interface, right, for example if you see here interface FA1/0, so I'm giving here the 10.129, right, IP address to this particular router or this particular interface part, right? And also I am giving here I'm configuring here the DHCP pool of net2, that is my second DHCP pool, right? And here also I am giving one of the range for this particular DHCP pool, that is 10.128, and whatever the DNS server and default router I am going to use, so I am using this particular routers this particular interface IP address to that particular DNS servers and default router, right? And the same thing I am also going to do with this third part, that is FA0/1. So here I am going to use I am giving here the IP address 10.65, and net DHCP pool network 3 I am going to use. This is nothing but the third DHCP pool, right? And from that I'm using this range of the series of IP address, that is 10.64, right? And if you see again the DNS server and the default router which will be having IP address, that is nothing but my routers this particular interface's IP address, that is 10.65, right? So in that way you need to provide this three interfaces, right? So three different IP I have given, right? So if you see here I am given the three different IPs over here, right? And as well as I have configured a different DHCP pool on this particular interface part, right? And after that whatever the PCs you are going or end devices you are going to use, right? So what you need to do is you need to give them as a on DHCP, right? So that it will be automatically fetched IP addresses from that particular server pool, right? DHCP pool, right? So if you see here I am giving as a DHCP for this software development one, right? It will be get automatically. Then for this particular HR also I am going to give the DHCP, so it will be get IP address from that particular server's DHCP pool. And here also if you see the it will business analyst also give the given the IP address from that particular server pool, right? So after that if you again cross check with this particular again whatever we have done before the subnetting part, right? the software developer should ping or should send a packet to this particular software tester, right? So previously what happened, that particular switch will be broadcast to each and every department, right? But here if you see, it will not able to send it to each and every department, right? So it will be send it belongs to that subnet only, right? So whatever the switch will be sent packet to this particular test, that particular belongs to subnet only, and it will be again pass it the acknowledgement to this particular software developer, right? So it will be able to help us to we cannot send a traffic to all the department, right? We cannot busy all the department unnecessarily, right? So for that, this particular subnetting will be required, and it can be configured very nice way, right? So this is nothing but first part, that is part A for the subnetting, right? So we will just move towards this the packet tracer part for it, right, first, and then we will move that particular static routing. Okay, so I will just open that Cisco packet tracer. Okay, now if you see here, this is your first network, right, which I have shown you, right? So if you send a packet from this particular SD to this particular router, so if you see it is successful, right? So this system to system, if you send, it is also a successful one, right? And if you see, if you wanted to check this particular what is the configuration for this particular router, right? So just double click on this particular router so that it will be get open, right? And you will check its configuration under this particular, for example, if you see from this particular router, the fast ethernet 0/0 port is an active port, right? So in interface, the fast 0/0, if you get this the IP address, that is 192.168.10.1, right? So this series IP address this particular router is having, right? And we are providing here also the DHCP pool in this particular router, so that if you see the configuration of all the PCs, right, then it must be DHCP enable, right? So if you see here, the DHCP is enabled in that particular software developer PC, right? And it will be getting IP that is 10.3 series, right? So DHCP request is successful for this particular PC, right? So like that, all the PCs is having my DHCP pool. It will be getting IP address from that particular DHCP pool which we are configured in this particular router, right? And then we have again the second network, right? So if you see here, for example, from the software development to tester, I am going to do, right? So it will be successful, right? But what happened, all the switch which we are broadcasting all this packet to all the department, right? So it will be unnecessarily causing bandwidth, unnecessarily causing the services of this other department, right? So we don't want all these things, so that's why we are going to include this particular subnetting part, right? And we are going to create some three different DHCP pool over the here, right? And also we are going to provide 3 different IP addresses to each and every interfaces for this particular router, right? So if you go in this particular router's configuration, right, so double click on it, okay, and just check the its IP addresses in the configure, right? So if you see the fast ethernet 0/0, it having some 10.1 series, right? So then the fast ethernet 1/0, it having the 10.129 series, right? And if you see the subnet mask, right, so it is nothing but my subnet for that particular network, right? So it having all these 3, and the last one is having the 192.168.10.65 again, right? This fast ethernet 9/0, right? So all the configuration you will check in this particular GUI as well, right? So we have seen in the lab manual in the CLI level, right? And on this particular Cisco packet tracer on GUI as also, right? So in that way, this particular thing are getting work, right? And for this particular SD0, if you are going to check whether DHCP is enabled or not, right? So you will find out that the DHCP is enabled from each and every devices, right? For the end, if you see in the at the end perspective, right? And if you are going to send a packet in between these, right, so it will be successful one, right? And if sending the packet again from, for example, in between these are so it getting successful, right? So this is nothing but your subnetting part, right? So what we have covered in this particular part A, right? So I hope you will understood that how the subnetting can be created, why the subnetting will be needed, and how it going to be configured on this particular through CLI as well as through GUI as well, right? So that's it for part A part, that is the subnetting. Okay, thank you for joining.